Hello everyone, I'm Kevin Hardy. Welcome back to Munro Live. I apologize about my voice. I lost it during the May the 4th Cybertruck event and been kind of struggling all week since then. So today we're going to go over kind of like a high level review of the suspension systems, compare the Cybertruck to the other EV trucks that we have in the building here, similarities and differences. And we're going to go essentially straight to the front suspension from there. So one thing that we really like about the Cybertruck is its upper control arm. I know there's already some discussions about this online because I believe one of these have bent, but we have seen a similar execution. I went on a Acura MDX, which we actually in some ways like a little bit better. But one thing that we do like about this, when you look at this, typically steel control arms or clamshell, so you'd have an upper and a lower, seam welded with some MIG welding operations around the perimeter of the control arm itself, which does in some way damage the metal and the properties of it thereof. But from our perspective, tooling, right? Two sets of tools, assembly operations. So that's one thing we do like about this, and it kind of lends to some aspects that we've seen throughout the vehicle to try and get cost out of the vehicle itself. They are still welding the control arm to the bushing can itself. The Acura MDX that I mentioned before essentially presses the control arm continues outward with some piercings, and they press the bushings into it, so there's no welding operations at all. But this is one thing that we do like about the Cybertruck. Depending on how you essentially nest the material within this, it could be hit or miss on a material usage perspective on whether it's less material than a traditional clamped control arm. But from a tooling perspective, most certainly less capital investment itself. So coming down to the front knuckle of the Cybertruck. The gooseneck portion of this is arguably one of the tallest that I have seen, personally. One thing that we do find interesting as this kind of comes up here, your ball joint sits here for the upper control arm. Roughly, I think this is actually the wrong side, but it sits here. So you can see the natural packaging space itself for the front tire. Not that many vehicles don't do this, where they bring the gooseneck back inward or outward on vehicle. But it's a little less typical on trucks. So both the Rivian, the F-150, essentially orientate the top portion of the knuckle inbound, or kind of more in line with the knuckle itself. And one of the biggest advantages here is tire and wheel packaging. So if you can imagine if the tire was sitting here without the ball joint in the way, this is a very similar knuckle to the regular F-150, which is also very similar to the Raptor. So you have tires from a 265 range all the way up to a 315, and then on the larger Raptor R, like a 37-inch tire, where you're able to package a very, very large tire on this vehicle. Same thing with the Rivian. The machine there is flat and kind of bolts in from the side. A little bit more flexibility as far as that upper ball joint is concerned with a larger tire. Whether you think it's warranted or not, larger tires are often an aspect of people's personal trucks and even like utility trucks, as far as municipal vehicles, government vehicles, things of that nature, for firefighting, stuff like that. So one thing that's kind of interesting is when you look at how efficient the upper control arm is, and maybe even concerns about its durability, I wonder if essentially, aside from packaging and just overall suspension geometry, is this kind of an enabler to keep the tire size on a Cybertruck relatively reasonable, and then the loads, therefore, brought into the vehicle reasonable and controllable as well? So, obviously it's a little less complex, and it can be, right? So when you look at the overall system of essentially a short, long arm setup, which is what we have here. So you have the upper control arm, the knuckle itself, and I'll loosely put this together, and then the upper. For this style of suspension setup, not that you don't see any loads with the upper control arm, but essentially it's helping keep it's essentially controlling camber, right? So keeping the wheel from cambering out or excessively cambering in, and it's controlling the arc of the suspension as it travels through its entire motion, the motion ratio itself. So you have the upper control arm on this style. If this was a McPherson strut, you'd have this dampener mount to a knuckle, and it would load up straight into the shock tower itself. But these are bolted in the shock tower. The strut goes from the lower control arm through this into the shock tower itself. And the knuckle itself then essentially packages your unit bearing. Here, if it's front wheel drive or four wheel drive or all wheel drive, whatever it is, your axle would pass through there. Steering is controlled here as well. And actually, this particular interface, the little nugget that was on here, that was bolted on here, where this is a bit of a point of kind of controversy on what this actually do. I think Jordan and I are still sticking with small overlap rigid barrier, right, for the different wheel sizes to help engage this. I'd love to know a little bit more if it has something else to do, like if it's a tuned mass. Typically though, when we see tuned masses on suspensions, they're rubber, they're cast iron, things of that nature, and they've never been bolted here. So the proximity for that nugget in relation to the wheel envelope is definitely pushing our opinion at this point to small overlap and helping with crash, as far as controlling how this wheel potentially and knuckle assembly moves and crash. And then you have the lower control arm. So for this particular vehicle, it has a very similar layout in the rear as well. So I think this is actually, yeah. So we've kind of got a concentric bushing here, which is moving with the overall motion of the control arm here. One that is perpendicular to that. This is typically for comfort and helping with NVH and locating the wheel itself, being fastened straight in Z direction itself. And then the lower control arm is carrying the most of the loads, right, for any suspension setup thereof. So typically, this is aluminum can be for a whole potential reasons. The strength required, balancing that against the weight, and then just packaging. When you look, this is relatively simple and elegant as far as how it's arrayed, a very simple A. As we get to the lower, you start to see the complexity of wheel envelope packaging, other parts of the suspension where we're moving and getting things around. And castings or forgings are very well suited to that because essentially, aside from the runners, which you can see here where they're kind of being machined off, for material, they're very efficient as far as how much of the material it takes to make the part ends up being in the part. So while lower control arm's a little tough on the aluminum side, typically they're a little bit more costly. And steel for high volume applications typically wins out. That for lower volume applications and just certain packaging situations, sometimes you want to be in aluminum, forging, just because of the shape that you need, or if you're trying to get it fracture a particular way for a crash event itself. But you can see here, just the complexity associated with this in contrast to the upper control arm. So when you go to essentially the unit bearing, nothing too crazy here. It is 6 lug Gen 3 scallop flanges, pretty traditional, kind of a GKN style interface with the axle itself. Not that we were expecting to necessarily see, an integrated assembly like we saw on, I believe, the rear of the Ioniq, but this is something that's pretty neat. That does make maybe service a little bit more troublesome down the line, but as far as integration, there's a whole series of seals and packaging stack up that just is not present with this type of execution, which is kind of interesting. So to further expound, what's a little bit unique here is what you can see here is this is, again, a traditional kind of Gen 3 unit bearing. So you have the flange itself that's mounting to the wheel, the bearing assembly, the flange interface, which is containing the bearing, and then the interface itself for the axle shaft, right? Now, when you compare to this, it's overall in similar kind of shape and size. You have here your flange itself. You can see the bearings. We've kind of cut and filled this with resin. But the difference here is instead of this whole interface, and you can see the depth difference between these two, you have grooves here and you're seeing the balls for a constant velocity joint. So this is all integrated. This whole aspect of the seal for the bearing interface has all been eliminated and is now part of essentially the axle assembly together. So your CV boot, which would seal out this joint here, is now also sealing out the, the bearing itself from the world and the contaminants within it. So that's one of the advantages, of this style. But as far as manufacturing, now, if I had a CV here, you're essentially loading the entire CV through a knuckle assembly and then securing it there. So it's a little bit more to manage on that side, but from a weight and packaging standpoint, it's a pretty interesting enabler. And again, something that we haven't seen until we saw it on the Ioniq itself. It's just something now that we essentially are looking for in every vehicle after finding on the Ioniq.
Thanks to the 3Dimensional Services Group for sponsoring this video. Whether you're looking to source metal stamping, precision CNC machining, laser cutting, welded assembly, or plastic injection molding, the three-dimensional services group should be the source to transform your EV, aerospace, appliance, or technology designs into reality, while also providing a bridge to start of production.
Hey boys and girls, I'm here with Dan, and we're at Three-Dimensional Services Group. And Dan, this is pretty impressive. Why don't you give us a little background on what you guys do here?
Okay, well, the Three-Dimensional Services Group was founded by Douglas Peterson 31 years ago. We've grown into the world's largest, most capable, and most agile prototype and low-volume manufacturer. In essence, we're a job shop on steroids. We work with the world's most innovative companies to validate their designs, and then we're able to take our low-volume manufacturing processes and scale them across a massive amount of equipment to allow us to support volumes that a traditional prototype shop would never be able to support. We're always working with our clients to accelerate their product development timelines and enable them to be as successful as possible by bringing their products to market as quickly as possible.
As you come around to the front, the vehicle itself here, this front cradle, this is literally just essentially, it's a very similar execution architecturally to the Model 3, Model Y, just scaled up essentially for the Cybertruck. That makes sense to me in a lot of ways. You understand the risks, the manufacturing strategies, and load inputs to this. This is not surprising in any way, shape, or form that we see this within the front of the Cybertruck. Tesla understands how a steel cradle like this works with a gig casting. So again, unsurprising. One thing that's a little unique, and as far as Tesla executing these front cradles, they essentially do this kind of D-loop out and around the motor itself, supporting the motor. And then they have these stanchions that kind of come up here to the mid portion of the casting. And they have a slip plane here. So on the Model 3, Model Ys, it's a simpler bracket that kind of just sleeves over this that bolts to the body. But this is something that is atypical in other vehicles, but is becoming, as Tesla releases more vehicles, more typical in a strategy that we see throughout their vehicles. As we kind of wrap around to some of the rear suspension bits, Jordan and I did talk about the benefits and associated with stampings. One thing that's interesting from the rear lower control arm in comparison to the front. So the front lower control arm is the only control arm that is aluminum. Aside from the cost advantages with the material, one thing that's kind of interesting is when you look at that manufacturing process, setting up the tooling for that, you essentially have to have a series of duplicate stations to get the volume you need. When you see how much steel is used, especially stampings, that does lend yourself well to essentially a high volume application. Front control arms get a little bit more tricky as far as packaging space and what you need to work around. So it's not that it's uncommon to see a casting in the front, but it is a little more interesting to me to see that everything else is stamped steel with the vehicle itself, being a simple short long arm style for both the front and the rear. The knuckle, a forged aluminum knuckle, nothing too crazy here. Most of the other rear components are actually still in process as far as being tore down with their sway bars and things like that for the other parts of the system and being scanned currently. So that's why they're not on the table right now. The upper control arms, as we kind of come around here for the rear, similar to the front, being again, a large steel stamping with selective use of reinforcements within that control arm, specifically for this upper ball joint sleeve here that they have. You have kind of a double shear welded joint. Just rigidity where they need it. Again, these are smaller pieces, smaller presses, or you can nest them on a larger press and get more parts out per hit. So it is efficient, from a cost perspective from that. And one thing that we did kind of speak to a little bit earlier is a little more uncommon to see the control arms bolted to the body of the casting than other vehicles that do cradles. A lot of times you'll see the rear up control arms as a whole complete unit being decked together. The Cybertruck rear cradle, it's very similar to the front cradle in that respect, where these are already on the body waiting for the rear drive module and cradle to be decked with it. So that is one thing that's a little bit interesting with respect to that. Some of your larger castings and forgings, like the front knuckle itself, the rear subframe, They are made in China, which is kind of interesting. We saw that also with the Model S Plaid. All your stampings here are marked made in the US. Cradle, excuse me, for control arms, the cradle made in Mexico. So we're seeing a plethora of assembly locations, leveraging essentially where you have some low cost opportunities and close proximity as well, as far as shipping things and getting some of your heavier components to the factory a little bit faster and ideally in a little bit more cost-effective manner from a logistics perspective. I'm not surprised to see as many of these parts that are cast or made in China in comparison to the Model S Plaid. But one thing that's been interesting is there's USMCA, so United States manufacturing content of parts is very important, and managing that balance of how many parts are made within the US, how many parts are made outside the United States is important, and it's something everyone is balancing almost continually as products develop and improve. So it'll be interesting to see once this vehicle is completely torn apart and we were to look at something like the Model S Plaid, volume's a little bit lower, but where Tesla is going for various parts as far as place of manufacture or part origin. So now, one of the things that I know Eric wanted to talk a lot about is the actual suspension system itself. So the Cybertruck does have an air ride system. This is common with other Teslas as well, not as parts, but as again in strategy. The other vehicle that we have here that is not Tesla, the Rivian, does have an active chassis system as well. Theirs is considerably different though in overall approach. So when you look at the air dampeners here for the Cybertruck, so here's the front and here's the rear, you can see as far as material selection, lots of use of steel throughout with just the overall like dampener cap being cast aluminum itself, steel, and then lots of use of rubber EPDM to keep contaminants and things of that nature outside of the bladder assembly and shield. When you look at the Rivian itself, just in general, not only is the system, twice as complex because it's an air over hydraulic system, but all the materials throughout are more costly, right? So we have forged, yokes for packaging, getting a axle through this. So a different strategy altogether as far as packaging and suspension, but you can see as you go through the rest of the body of the dampener, just material costs that are notably higher on the Rivian itself. Cool thing though about the Rivian is it doesn't have any sway bars. So one advantage essentially of having the air over hydraulic system is as far as drive modes, drive height, all that stuff. I don't want to say it's infinitely variable, but it's pretty much close to that. As far as whatever drive mode you're putting it into in various situations, it can adapt because essentially, truly, each corner of the suspension is isolated. The one thing I don't like, even though everything is packaged relatively well in the Rivian, you have a lot of components, especially some of your larger aspects for your hydraulic pump and your air pump that hang in the rear quarters of the truck itself. Relatively exposed, and I say relatively, if you were to get into these areas with like rock impingement, you're having a bad day with your Rivian regardless. So they're not overly vulnerable, but when you look at the Cybertruck, the air pump itself and the reservoir are packaged above the rear gigacasting in between it and the bed assembly and very well protected essentially from the outside elements. I think unfortunately we were real disappointed once the inner bed assembly kind of came off this to see a completely separate air reservoir that wasn't integrated with anything else. That's something that indicative of more traditional manufacturers. The Rivian is very similar in overall size and volume and even packaging location. There's a little bit more rearward on the backside of the cradle. But I think we were all hoping to see something else, integration with that vessel, maybe with the casting itself, bolted to it, just a little more than we have here. The truck, was trying to get to market as quick as possible. And frankly, this is something that we work with all the time with our more conventional customers is trying to get integration and get things to market quickly, which is frankly very difficult. Now, the lines you can see here kind of coming out here. I do like that the rear portions of the air lines, just like the primary portions of the air system itself, are well protected. Supply to the front side runs up each side of the rocker sill, exposed for sure, but not overly exposed. And then they kind of tuck up in the front portion of the gigacasting and then run to their respective corners. So now that I'm inside the rear of the Cybertruck itself, you can see the pump. It's sitting inside of an injection molded cradle here. It's isolated. And you can see just how little resistance is present within that system to keep the noise to a minimum. The Rivian itself also has another encasement around this where there's some PUR foam and then a layer of EPDM rubber around that foam enclosure to help keep the NVH or the noise, vibration, harshness of that to a minimum. So you can kind of see here, you have the pump, it goes in the vessel here, and then right here, reservoir, front left, rear left, front right. So all these are labeled essentially of various lines coming out of the reservoir, going to each corner of the suspension. So personally, I'm not a huge fan of air ride just from the complexity standpoint. I've had friends that have worked in air ride, they don't like it long term, but air ride is a relatively cost-effective way to get essentially a lot of comfort in a vehicle. The Ram 1500 has had air ride for years now, numerous generations of that truck, and that coupled with the multi-link rear suspension that they have on the Ram is arguably best in class as far as ride and drive comfort and the dynamics itself. Lowering and raising the vehicle, so changing your dampener rates are advantages of doing an air ride suspension. So there's a lot to be said for it. Typically, I think it falls on the air of comfort and drivability versus typically performance. You don't often see on performance vehicles, there's no 911s, Shelbys, or anything like that are running air ride. They're typically on the electromagnetic spectrum of active dampeners where you have metal flakes in the fluid and they're changing the rebound and all that within the shocks electronically to keep weight down and packing space, open to the vehicle itself. One advantage I do think, the downside of those type of dampeners, that EDD or anything like that, is typically they're built. I'm going to hop out of the Cybertruck. Typically they're built in clean rooms. So from a cost perspective, when you're assembling those dampener batteries, it's very, very clean. You can't have the contaminant, anything within the fluid itself be contaminated. So that does drive costs there. And frankly, I think some OEMs can understand the cost a little bit easier with air ride versus some of those electropneumatic systems, because there's a lot of IP, patents, and frankly, to most of these companies, they're essentially black boxes in terms of cost and understanding what actually is in them, unless they were to do a complete utter teardown and then understand fully what is going on with each assembly step and process. So I think the air ride offers a nice balance between the cost of the system and performance for what you're doing on trucks. So that's typically why you see it in these segments and not necessarily in more weight or performance oriented segments like cars. It is interesting to see how things are laid out and the manufacturing choices, places of manufacturing origin, and things that Tesla has decided with the Cybertruck itself. Arguably a relatively simple short long arm for the front and rear. And I think maybe some of those choices that we're seeing here for both materials and even suspension system are to help offset, the cost that we're seeing, elsewhere in the vehicle and just even time to market. So I hope that kind of helps give some insight, at least at a high level, to the other EVs that we have here and some of the pros and cons with the Cybertruck. Thanks for watching. I appreciate it.